This video is on dividing complex numbers. I want to review for a moment the complex conjugates. So if here's an imaginary number, you have your real part and your imaginary that involve the entire complex number. For you to take the conjugate, you change the sign in front of that imaginary piece. So the conjugate would then be 5 minus 6i. In this example, the conjugate would be negative 4. Change the imaginary piece to a positive 4i. And then our last one, change the imaginary piece to a positive 2i. So those are the complex conjugates. We're going to move on to now dividing two complex numbers. Please make sure you write down this important piece. When you divide by two complex numbers, you must multiply the numerator and the denominator by the conjugate of the denominator. Take your time and write that down, please. So first example, 3 plus 7i divided by 8i. So you're taking a complex number, dividing by a complex number. So off to the side, ask yourself, what's the complex conjugate of 8i? Well, that is negative 8i. So we're going to multiply the numerator and the denominator by negative 8i. So I'm just going to rewrite the original question again as a fraction. So 3 plus 7i, dividing it by 8i. And I'm going to throw parentheses around here. And now I'm going to multiply the numerator and the denominator by negative 8i. Now let's go ahead and multiply. So we're going to multiply like we're foiling or distributing. We're going to take 3 and multiply it by negative 8. And we get negative 24i. Then we're going to take 7i and multiply it by negative 8. Then in the denominator, we're going to multiply 8i times negative 8i. And we get negative 64i squared. Now we have some simplifying to do. In the numerator, I'm going to leave that negative 24i alone. You remember what happens to I squareds? They are replacing with negative 1. If you want to think about it as just changing that negative 56 to a positive 56, you might be there now. And then in the denominator, this negative 64i, again has an I squared, so just change that to a positive 64. Now, we have negative 24i over 64, I'm splitting up the fraction, plus 56 over 64. Now reduce the fractions. So I'm going to reduce that first fraction by 8. So negative 24 divided by 8 is negative 3. 64 divided by 8 is 8. In the second fraction, I can divide that by 8. And the numerator, denominator both by 8. And there's my final answer. Oops, I should probably put this as an imaginary second. So it should be 7/8 minus 3i eighths. Real, then imaginary. Second example, it has a complex number divided by a complex number off to the side. What is the complex conjugate of 1 minus 3i? That is 1 plus 3i. So we're going to multiply the numerator and denominator by 1 plus 3i. So I'm going to just go ahead and rewrite this equation, or this expression again. 2 plus 5i, throw parentheses around it, and then 1 minus 3i. And now I'm going to multiply the numerator and denominator by its denominator's conjugate. And now we have some foiling to do. First, outside, inside, last. You should be pretty good at foiling now. So I'm going to go a little faster. If you need to slow down and pause, you're welcome to do so. So 2 times 1 is 2. 2 times 3i is 6i. 5i times 1 is 5i. 5i times 3i is 15i squared. Over, now let's go down to the denominator and do our foiling there. 1 times 1 is 1. 1 times 3i is 3i. Negative 3i times 1 is negative 3i. And then negative 3i times positive 3i is negative 9i squared. Now let's do some simplifying. Two just stays as it is. These two are like terms, so they will become 11i. We have a 15i squared. Remember what the I squared does is it drops the I squared and changes it to a negative 15. And we have a 1. These are like terms, but they're positive 3i and a negative 3i, so they cancel out. And now we have a negative 9i squared. That I squared, drop it, and change the sign to a positive. Continue on. 2 minus 15 is negative 13 plus 11i. And then 1 plus 9 is 10. Now we just split up the fraction into negative 13 tenths plus 11i